All right, so in this quick video, we're going to talk about how do you determine which quadrant the terminal side of an angle lies in if we know information about two or more trig functions. So to start this conversation, I'm going to remind you about this little diagram that's called a cast diagram. And it's called a cast diagram because if you put the letter C-A-S-T starting in the fourth quadrant all the way around, you spell the word cast. This diagram is a mnemonic device that will tell you which functions are positive within which quadrants. So for example, in the first quadrant, your sine function, your cosine function, your tangent function, and all their reciprocals are all positive. So the A stands for all. All the functions are positive. In the second quadrant, we get our sine function, positive, as well as its reciprocal, but nothing else. In the third quadrant, we have our tangent function, positive, but nothing else. And its reciprocal, sorry. And in the fourth quadrant, we have our cosine function being positive, as well as its reciprocal, and nothing else. Everything else is negative. So when we're looking at problems like this, we are using the clues that the tangent of theta is positive and the cosine of theta is also positive. Okay, well, there's a couple of things that we want to, we're going to do this just like any other problem, but then I'll show you the shortcut for this particular problem in a second. All right, so where is tangent positive? We can say that the tangent is going to be positive here in the third quadrant and here because everything's positive in the first quadrant. Okay, so we can say this is going to be either quadrant 1 or, quadrant 1 or quadrant 3. Okay, and then we think about cosine. Where is cosine positive? And of course, cosine is positive in that fourth quadrant and above it in the first quadrant. So quadrant 1, oops, let's go backwards, sorry. Quadrant 1 and quadrant 4. Now, if we look at both of these clues, this is 1 or 3, and this is 1 or 4, what do they have in common? They've got quadrant 1 in common, so this is what it must be. Now, I told you there was a shortcut on this one. That's because there's only one quadrant that more than one of the main functions is going to be positive in. And so that would be quadrant 1 because of that all thing going on there. All right, let's look at another example. The sine of theta is negative and the cosine of theta is positive. So let's first concentrate on where the sine is negative. Well, I know that the sine is negative where it's not positive. So the sine is positive in quadrant 1 and quadrant 2. I'm really interested in where it's negative. So that's the other one. So quadrant 3 and quadrant 4. So quadrant 3 and quadrant 4. All right, so now, where is the cosine positive? Well, let's think about that. Cosine is positive in quadrant 4 and quadrant 1. Quadrant 4 and quadrant 1. Whoops, backwards. 4 and 1. So if I'm looking at the clues, what is in common? Or where did I put the 2 marks? There, and that's going to be in quadrant 4. Okay. The problems to the right are another set that are like this. What is different about these is that we have some reciprocal functions in here, secant and cotangent. So we need to remember that the secant of theta is equal to 1 over the cosine of theta. And that means that the secant is going to follow wherever cosine is positive, secant is positive. Wherever cosine is negative, secant is negative. And the same is true for cotangent. Cotangent of theta is equal to 1 over the tangent of theta. So the signs of tangent will also hold true for the signs of cotangent. So let's look at, let's get rid of some of these markings. All right, so let's look at secant of theta being positive. Secant of theta is going to be positive at this in the same quadrants that cosine is positive, and that will be in quadrants 1 and 4. Come on. So this is 1 and 4. And then where is sine positive? Well, sine is going to be positive in 2 and 1. All right, so 1 and 2. And so in this case, we've got a quadrant 1 thing going on. And then in the example below that, we already know cosine is positive in 1 and 4. So let's think about where cotangent is negative. That's going to be where tangent is negative. So think about where tangent is positive. Where is tangent positive? Tangent is positive in 1 and 3, so tangent would be negative in 2 and 4. All right, and so that is what we're looking at there. And so of those quadrants, we can see that it's going to happen in quadrant 4. So I hope this helps you with this concept. It's a matter of looking at the clues and trying to figure out the appropriate location. So put on your sleuth hat, and I'll see you next time.